Greetings, folks. This is Scott, Game Audio Institute, once again, and we're back in um, the world of Constellation. So I have actually been working very, very heavily on ChucK today, and it took me quite a few hours back and forth, different things, all kinds of stuff like that. Um, I I got some tips about some things to check out from like other students' projects that were using the Tunity plugin. But so then I took a look at at least one of the student scripts that I saw, and it was just, you know, I know enough about programming to say that that was really bad programming. It was just, in other words, instead of having like a list of things or an array of things, it was just each individual event was like, you know, done that way. So I started thinking about, I'd actually earlier asked ChatGPT to write me a ChucK script that would do something, and I don't know whether it actually worked or not. I didn't really try it because it was actually in a couple of parts and stuff like that. Anyway, I then asked it to write me a thing that would generate a bunch of chords, like a sequence of chords. So it might be helpful to sort of talk about what the Constellation sort of concept as it currently stands, right? Everything is pretty much based on the concept of the layer. Okay, so the layer is that 16 by 16 grid, right? So, in that grid, what you're basically doing is you have a playhead that is effectively running across left to right, and it's going to potentially play up to 16 notes at a time. And every time it hits that column, it's going to play however many notes are lit up, right? That's the idea. So what I had to do was try to figure out how I could make this happen in ChucK with arrays, with a list, essentially. So there are some, things where if you know a little bit about C# or C++ programming, some of this sort of makes a little bit of sense. But I just want to show you, I've now finally gotten pretty much exactly what I need. Now, what I don't know at this point in time is how well I can interface this with Unity. But at the moment, I've got it working in ChucK well enough to demonstrate. So we can kind of go there and check it out in what they call Mini Audicle, which is their sort of editing environment. Now, there's ways to do this also inside Visual Studio Code, but for now I'm using Mini Audicle, and it was decent enough for this particular purpose. I don't really need it to do much at the moment. Okay, so but here is what's going on. So it turns out that I like all these kinds of things it tends to ignore. I'm not quite sure why exactly, but the main issue is this one. We've got this currently set to a note duration as we need to adjust this. And I was hoping I could make something like a beat be a certain amount of a second of the note duration and stuff like that, but whatever. I'll figure that issue out. It's not a problem. But here's how we're getting through. We've got 16 positions to be read by the playhead. We've got 16 gates. Now, that's actually not at each position because we don't want to say, hey, don't play any notes. We were going to say, don't play certain notes in this chord, right? Depending on things. Now, what I'm doing is I'm randomly assigning notes to things, essentially, for right now, because I have no actual hooking up with Unity right now. This is just ChucK by itself, okay? So this is a ChucK lesson, effectively. So what I'm doing in this case is then I'm establishing my note scale, which is indicating the number of notes chord that are played in the position. And then I have the sine-osc voices. I'm creating a sine wave oscillator, 16 sine wave oscillators for each note in the chord. That's what we're doing. So this is just setting everything up, essentially. Then what we're going to do is we are going to set what the note scale is and create those not create out the oscillators, but assign the oscillators. We actually did the oscillators here. So I should say assign oscillators, not create oscillators. Good to have that. So the deal is that what it's going to do is randomly pick between 40 and 80. An integer number, and it's going to apply that to the note scale note number. Okay, so note number is this integer, and we go up to 16. So it's just basically looping through 16 values. When it does that, it picks a number between 40 and 80, and then it is going to apply this MTOF, MIDI to frequency. That's what MTOF means. and it's going to go MIDI to frequency, and then the note scale note number is going to be applied. So it's going to apply that MIDI note to that frequency and assign that result to the voices at the same exact, that same array member and its frequency, basically. That's the deal, okay? Then, this is all just set up at this point in time. Then we define a function to play a chord. Now, this was actually generated by ChatGPT partially. I have eviscerated it almost completely in terms of just like looking at the ChucK documentation and then coming back and doing this stuff and trying to figure stuff out. Okay, so the first thing that we're going to do is we're going to create an envelope. So we do want one envelope for the whole chord, for that whole position. We're not creating 16 different envelopes per position every single time. We're creating one envelope when the chord is called, okay? And then we can set characteristics. Each one of these characteristics is, in fact, A, D, S, and R. So basically what this is a 5 millisecond attack, a decay that it corresponds to a quarter of the beat length currently. It could do anything I want if I wanted to. So essentially it's a decay, a sustain of 0, and a release of 1 millisecond. So basically an immediate release. Then what I'm doing is I'm basically setting this to the envelope. In other words, I'm creating the envelope settings, basically. That's the deal. It's called envelope. So ADSR ENV. That's what I call my variable. Okay. It's an interesting thing. So it's kind of similar to C# in that respect. You're creating the type first, and then you're creating your variable that you have. However, if you have to assign it a function, it sort of does this reverse Polish notation thing where you create the number first, and then you chuck it. That's what this ChucK symbol is, to the float variable for this. So if you want to assign numbers to things, that's kind of how you have to do it, which is a little bit, it's a little bit weird. You get used to it. Anyway, so we create the envelope every time the chord is hit. We've got a limiter. We could possibly have created the limiter earlier. We don't necessarily have to do it every single time we hit a chord. So that might be extra, whatever you want to call it, processing. So I might put the limiter over here or something like that before I hit the function, because it doesn't need to be defined every single time that the chord is hit. Anyway, so the deal is that each time the chord is called, it's going to randomly open the gate. So here's the deal: math random 0 1 gate. Now I could have done, I don't know how to do booleans per se specifically, so I just chose to do single integer numbers essentially. So what happens is that it's going to assign that number to the gate note. So note is my loop that I'm basically doing, the value of the loop. And then I'm basically going to go and say, okay, if you're not 0, here's the gain. Now, I have to set this very low because I'm running it to a limiter, but also it tends to distort pretty easily, I have to say. So we have to keep the value fairly low. As you can see, 0.008. If you put this at 1, it would be massively, massively distorted, because you're talking about 16 voices or any number of up to 16 voices playing at the same time. And you get gain staging issues, basically. So this is trying to get around the gain staging issues by making the initial volume really, really low so that, you've got enough headroom, basically. So then what happens is you basically look at the thing, you do the voices, then you assign the gain. Okay, so that's the idea. So you're assigning the gain. If the note actually runs or plays, then you put that note in there. If it does not run, then it goes into sort of like the 0 value. Now, there might be a way of throwing away the note in some way or something like that, but for right now, that's what I chose to do, was just reduce the volume to technically nothing. I hope that that's nothing, unless that's a dB. It might be a dB rating, but I don't think so. Then I basically take any note that is happening in this array, I assign it to the envelope, and then I assign that envelope to the limiter. And that's how it goes out. And we already know the limiter is already hitting the DAC. The DAC, by the way, is the main output, right? So the DAC is the output. Then we trigger the envelope using envelope key on, and the note duration is basically now. So we're just basically saying, okay, play the note at this point. And then we release the key envelope with envelope key off. Now, here's what actually does the playing. It basically plays the sequence of chords by going for int I, int16, blah, 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 I++, play chord, note scale, count ++, and then we're done. So that's what this is doing, basically. It's going through all of this sort of stuff, and I believe this will be exactly what I need in order to have one layer working in Constellation. So it's very exciting. And that's it. And the next time I do this, I would actually, it would just randomly pick different notes. So yeah. And by the way, in order to start that, you just click Add Shred. Yeah, I don't know why. There's all these terminologies that are really crazy. But anyway, I'm pretty excited about this. This basically gives me a basis from which I can address this inside Unity. Now, the tricky bit will be, can I assign, specific numbers to these variables? Well, specifically, it would be like the gate values, which you're turning on the node or not turning on the node. Can I assign the position value? I definitely have to do that. Although the thing is that, again, I'm going to be using ChucK's internal strongly timed timing in order to be able to do this kind of stuff. And then I'm basically having that go to Unity and tell the playhead to move. So really, it kind of starts at ChucK and then it goes out. But I do want to be able to do things like assign the individual notes so that I can make different scales or whatever. There's all kinds of stuff that we're going to have to do. This is just barely scratching the surface. Anyway, all right. So that's pretty much it at this point in time. I hope that was helpful or interesting to you. I don't know. We'll see. I'm getting the hang of working in ChucK pretty easily or pretty quickly, comparatively speaking. I'm able to just sort of, bludgeon my way through it based on my meager knowledge of C++ and stuff like that and C#, basically. So anyway, I hope this helps you get your game audio on, your procedural game audio on, that is. See you next time. Bye. Oh, we're going to be in Unity and doing more stuff, obviously, at that point. But the next step will be to hook it all up into Tunity, hopefully, with some kind of degree of usefulness. All right. See you then. Bye.